Alrighty, in this video we are going to be talking about polar FRQs. This video will probably be split up into two parts, just because I want to do all of the FRQs because I am out and I do want you guys to be prepared for the tests whenever I do come back. So let's go ahead and do part A. We have RB, the region that lies inside the graph of r is equal to 3, which is going to be my green circle. And then r is equal to 4 minus 2 sine of theta, as shown in the figure. And we want to find the area of r. Well, before we do that, I got to look at my sum right here, because it told me that theta is pi over 6 and 5 pi over 6 as my intersections. So this is going to be pi over 6. And this right here is going to be 5 pi over 6. And if I'm going to use symmetry, I'm going to be focusing on the right side and then multiplying everything by 2. You'll also notice that if I were to draw my radial line right here, it's going to split this region into two parts. I want this part right here from negative pi over 2 to pi over 6. And then I also want a part where I have pi over 6 to pi over 2. So if I were to do from negative pi over 2 to pi over 6, I'm going to have 1/2 the integral from negative pi over 2 to pi over 6 of 4 minus 2. Nope, just kidding. That is actually in relation to my green circle right here. So that right here is going to be 3 squared, which is just going to be 9. So this is going to be 9d theta. Plus I have my orange, so I have 1/2 the integral from pi over 6 to pi over 2. Then this right here covers my blue polar graph right here from pi over 6 to pi over 2 whenever I swoop it over. So that's going to give me 4 minus 2 sine of theta squared d theta. Now remember that this is only the right side of my region. Since it is symmetrical to each other, I'm going to multiply by 2, and if I do that, well, this goes away and this goes away. So I'm only left with my green and then my orange, add them together, and then call it a day. You guys can do that on your own in terms of putting this into the calculator. That's going to give us 24.708. This one right here, I think you could also do this algebraically. You could just multiply this out and then simplify that a little bit and see what you get there. But for part A, for the sake of time, I'm not going to do that. Just plug and chug into the calculator and then get 24.708. All right, part B. A particle is traveling along the polar curve r is equal to 4 minus 2 sine of theta, so that at time t, theta is equal to t squared for 1 to 2. We're going to find values of t when dr dt is equal to 1. Okay? So if I want dr dt, we got to figure what that is using chain. So dr dt is going to give us dr d theta times d theta dt. And I'm going to plug in everything I know. So right now I know that dr dt is equal to 1. I got to figure out what dr d theta is based off of me taking the derivative. So dr d theta is equal to negative 2 cosine of theta. And then d theta dt here, that's going to give us 2t. Okay. This is interesting because I have a theta right here and I have a t right here. And right now, I want to find values of t. I don't want theta. Well, if I were to look at the question, hopefully you notice that theta is equal to t squared. And if theta is equal to t squared, I can use that substitution right here. So that now I have 1 is equal to negative 2 cosine of t squared times 2t. Now, once you get that final equation right there, you are going to put this into the calculator. Put 1 for y1 and then put this thing right here for y2. Find the intersections. Make sure that your window is probably between 1 and 2 and call it a day. Now, whenever you are doing this, I would advise you to put this in rectangular format and not polar format on the calculator, just because you could easily find the intersections, and plus it's in time, so obviously you should probably do it in rectangular and not polar. All right, for C, for the particle described in part B, find the time t in the interval from 1 to 2 for which the x-coordinate of its position is -1, and then we want to find the velocity of the particle at that time. All right, so we want to find the x-coordinate for time t. So this right here is going to be x of theta is equal to r cosine of, not theta t. So x of t is equal to r cosine of t, all right? And we know that r is 4 minus 2 sine of theta. 4 minus 2 sine of theta of cosine t. Now, once again, we have a little dilemma because right now I have a theta right here. But remember that I could substitute theta to be t squared. So now I have x of t is equal to that lovely thing right there. And it told us that the x-coordinate is -1. So I'm going to substitute that to be -1. I am going to do this one together with you guys so that we can find this intersection together. All right, so we are going to put this into the handy-dandy calculator where I have -1 as y1. And then for y2, I have 4 minus 2 sine of x squared. Make sure that the square is in the inside. And then I have cosine of x. You want to change your window because it is from 1 to 2. And then change your y min and y max if necessary. But let's see if I need to change it or not. Let's graph it. And here I can see that I don't really have to change my bounds. You might have to on the 84, but on my little online calculator, I'm not. I'm going to go ahead and do second calc, intersect, and then find my intersection here. That is going to give me my intersection of 1.808. So I have 1.808. 1.808 for time t. Okay. Now, it says find the velocity of this particle at that time. So we are going to take the derivative of x of t, and we are going to take the derivative of y of t. So the velocity of 1.808 is going to be equal to x prime of 1.808, y prime of 1.808. Now we already figured out what x of t is right here, and then for y of t, that's going to be very similar, except instead of a cosine, we have sine. So these are going to be my two formulas, equations for x of t and y of t. I'm going to take the derivative, and that's going to be me using my little numerical derivative analysis here. Before I do that, I'm going to just copy this and then put a sine of x. So that's y2. I'm going to do math and derivative of y2. And the x value that we already found the intersection for should already be stored, just because we already had x is equal to 1.808. If it's not automatically stored, you could just type in 1.808. You're going to get the same thing. But here, it tells us that my value is, x value is -5.821. -5.821. So that's my x value. To find my y value at that, I'm going to do the derivative. Once again, but this is in y3. And I'm going to do that, and that's going to give us 5.979. 5.979. And that right there gives us my velocity at 1.08 when my position is -1. All right, so that is number 1.